Hello everyone, this is Om Prakash from CSIT branch. My ATT Tech Talk topic is Machine Learning and Optical Fiber Communication System. Now let us see what is machine learning. Machine learning is study of algorithms that improve their performance at some task with experience. Teaching a computer to automatically learn concepts through data observation. Let us see difference between traditional programming and machine learning. In traditional programming, we have to give data program to computer, then it's give output. But in machine learning, we have to give data and output, then it will show program. Optimize a performance criterion using example data or past experience. Role of statistics inference for a sample. Role of computer science efficient algorithm to solve the optimization problem, representing and evaluating the model of interference. Machine learning is no more like gardening. Seeds are algorithms, nutrients are data, gardener are you, plants are programs. Let's know about optical networks. Optical networks constitute the basic physical infrastructure of all large provider network worldwide. Thanks to either high capacity, low cost, and many other attractive properties, there are no penetrating new important telecom marketing as datacom, and there is no sign that a substitute technology might appear in the foreseeable future. Different approaches to improve the performance of optical networks have been investigated, such as routing, wavelength assignment, traffic roaming, and survivability. In machine learning algorithms are supervised learning algorithms, unsupervised learning algorithms, semi-supervised learning, reinforcement learning. Now let's see about supervised learning. We are given labeled data. Training data include desired outputs. Main objective given a set of historical inputs predict an output. Rejection output value is continuous. Classification output value is discrete or categorical. An example traffic forecast given traffic during last week or month or year. Predict traffic for the next period. Predict if available resource will be sufficient. Classification. Other example speech image recognition, spam classifier, house price prediction or estimation. Supervised learning. The algorithm is trained on dataset that consists of paths, wavelengths, modulation, and the corresponding BER. Then it is extrapolates the BER in correspondence to new inputs. Unsupervised learning. Available data is not labeled. Training data does not include desired outputs. Main objective derive structures, patterns from available data. Clustering finding groups of similar data and more decision. An example for unsupervised learning. Cell traffic classification. Understand if some cells provide similar patterns. Residential, business, stadium. This information can be used to make network resources planning. Other example, group the people according to their interests to improve advertisement. Unsupervised learning. The algorithm defines unusual patterns in the data consisting of wavelength, paths, bear, and modulation. Semi-supervised learning. Hybrid of previous two categories. Training data includes a few desired outputs. This technique also make use of unlabeled data for training typically. A small amount of labeled data with a large amount of unlabeled data. Reinforcement learning. Available data is not labeled. Rewards from sequence of actions. Main objective. Learn a policy that a mapping between in inputs or states and actions. Behavior is refined through rewards. Methodologically similar to optimal control theory, dynamic programming, Q learning, reinforcement learning. The algorithm learns by receiving feedback on the effect of modifying some parameters, example, the power and the modulation. Overview of other applications. Physical layer. First one is quality of transmission, QoT estimation. Second one is optical amplifier control. Third one is modulation format recognition. Fourth one is nonlinearities mutations. Now let's see how network layer works. It helps to predict traffic and virtual topology design, failure detection and localization, flow classification. Now let's know about quality of transmission, QoT. The concept of quality of transmission generally refers to a number of physical layer parameters such as received optical signal to noise ratio OSNR, BER, and Q factor, etc., which have an impact on the readability of the optical signal at the receiver. Such parameters give a quantitative measure to check if a predetermined level of QoT would be granted. Conversely, machine learning constitutes a promising means to automatically predict whether unestablished light paths will meet the required system QoT threshold. Let's see how optical amplifier control. When adding or dropping channels into from a VDM system, EDFA gain should be adjusted to rebalance output powers. An automatic control of preamplification signal power levels is required, especially in case a cascade of multiple EDFA to avoid the excessive post-amplification power discrepancy. Machine learning regression algorithms can be trained to accurately predict post-amplifier power excursion in response to the add or drop of specific wavelengths to or from the system. Modulation format recognition is also called as MFR. Automatic digital modulation recognition in intelligent communication system is one of the most important issues in software-defined radio and cognitive radio. Now let's see nonlinearities mitigation. Optical signals are affected by fiber nonlinearities, K effect, self-phase modulation, SPM, cross-phase modification, XPM, Q factor, chromatic dispersion, CD, polarization, mode dispersion, PMD. Traditional methods require complex mathematical models. Machine learning models can be designed to directly capture the effects of such nonlinearities, typically by creating input-output relations between the monitored parameters and the desired outputs. Traffic prediction and virtual topology design. Accurate traffic prediction in the time-space domain allows operators to effectively plan and operate their networks. Traffic prediction allows to reduce over-processing as much as possible. Supervised learning algorithm can be trained to predict future traffic requirements and consequent resource need. Let's see flow classification. Traffic flows can be heterogeneous in terms of protocols of HTTP, FTP, SMTP, etc. Services fixed versus mobile, POD, data transfer, text message. Requirements: latency, bandwidth, jitter, network, customers, human end users, companies, sensors, servers, or etc. Distinction between different flows in crucial for resources, that is, capacity, allocation, scheduling, SLS, QoS. Supervised learning algorithms can be trained to extract hidden traffic characteristics and perform fast packets classification and flows differentiation. Thank you for giving this opportunity to present my ATT Tech Talk.